All right, got this recording started. So I should have said this before I started the recording, but we're going to start with talking about pipelines and grid search. Actually, grid search first and then pipelines. And then we'll move into talk about the project. So first I want to talk about grid search. So grid search is basically the automated way to search through different hyperparameters. And it's actually pretty easy to set up. And you'll see that, the .fit, .predict still holds. After that, we'll talk about pipelines, which I was talking a little bit about that right before I started the recording. But let's say you wanted to scale your data, you can do that together with your modeling step without having to, do your fit, transform, and transform first. So we'll get there. Okay, so first, importing all of our usual things. The new things that we're importing today, we have grid search CV cross-validation. So if you're doing grid search, it's actually automatically doing cross-validation for you as well. And then there is a scikit-learn pipeline and our usual metrics and all that. So for this notebook, we're going to use that same data set that is in that function assignment that I sent you all. And standard, we're going to do our chain test split. Okay, so grid search is used for hyperparameter tuning. So later when I talk over the project guidelines, I'm going to want to see at least one iteration of grid search on a model. And what that means in the context of the project, I'll get to that. So for grid search, you have to think about a couple things before you set it up. One, well, the parameters that you want to search through. So whenever you're doing a grid search, I definitely recommend pulling up the documentation of the model. Actually, let me pull up the documentation for K-neighbors classifier. Okay, yeah. Let me pull this up so that we can look at this in conjunction with the grid search we're about to do. So your hyperparameters, because that's what grid search is for. Next, think about the scoring that you want to use. Now, what kind of scoring you want to use really does depend on your business case. So whether you want to optimize for accuracy, recall, precision, F1 score, something different, that depends on your business case. And you can actually tell grid search to pick the best combination of parameters that maximizes that specific metric. And we'll see some examples of that. Other parameters, CV, how many folds of cross-validation per combination of parameters. So you'll see with every model, they're going to do some cross-validation and you can tell it how many folds to do. And then there's verbose, which controls how much information is output. I'll also demonstrate that in a bit. And from attributes, I'll talk about attributes in a little afterwards. So to set up grid search, you first have to instantiate your grid search. But before you instantiate your grid search, you have to define the grid that you want to search over. So for k-nearest neighbors, for example, I mentioned that the two main hyperparameters that we adjust for k-nearest neighbors is n neighbors and weights. And the purpose of grid search is really to see, all right, I want to test 1, 2, 3, 4, 5 neighbors, and I want to test uniform and distance for weighting the distances. I just want to see like which combination is the best, because here there are 10 possible combinations, right? You can do 1, 2, 3, 4, 5 with uniform, 1, 2, 3, 4, 5 with distance. There are 10 possible parameters. So rather than just running 10 separate models, grid search does that automatically for you, does the cross validation too. So the way that you set it up is looking at your the key for this dictionary has to match exactly the parameter names here. And then for your values, it can just be any values you want. What I usually do to start is I actually look at what the default is, and then I go like up or down depending. And if it's something like weights where it's, either uniform, distance, you got to put those two. But yeah, you have to look at the values that each parameter can take for it to make sense. So for this example, we have these parameters that we're going to search through. And here we're going to instantiate grid search. Here I'm feeding in a k-nearest neighbors classifier as the model. And actually, let me pull up the grid search documentation. We're going to need that later too. Okay, so you see the parameters. The first one is the estimator object. So that's basically the model object. And the second thing you have is the grid and then scoring. These are the main ones that we're going to talk through. So we instantiate with our model first. we feed in the grid. So this is our KNN grid over here. I'm going to say scoring. I want accuracy because I want to, for this project, let's say I just want to optimize for accuracy. And we'll look at verbose equal to 0. Actually, let's start with verbose equal to 2. And then you actually fit on the grid. So KNN search dot fit. KNN search is basically the grid search, and then we'll fit that. Oh no, oops. Where did that come from? How did that happen? Weird. Oh, there we go. Okay, so with that, you can see that verbose equal to 2 gives you this output. Verbose equal to 1, I think gives you a little bit less, fitting 5 folds, blah, 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 totaling 50 fits. And then verbose equal to 0 won't give you any output. So if you want to adjust and see, especially if you have like a lot of data and like a lot of parameters that you're surfing through, maybe you want this to output just so you can see as it's training. Because this is such a small data set, it was pretty immediate, but with a large data set, this might have taken more time. Cool. So with that, we fit our grid search. So what this means is 5 folds for each of the 10 candidates. As you saw, actually, I didn't really point this out, but here you can do CV. The default is 5-fold. So because I didn't do CV equal whatever, it's going to do 50. It's going to do 5 folds per model. So here it's actually fitting my model 50 times for 10 different ways. Cool. So this is fit. Now, after the grid search is done, let me close this out. We can grab the results. And it actually comes in a, I want to say, I forget, does it come in a dictionary? Let's find out. So I think it comes, great. It comes in a dictionary, which we can turn into a data frame. So with this, you can actually see the fit time, the scoring time is just like testing time. So if you wanted to take that into account, and then you have your parameters. So the n neighbors parameter is here, weights is here, and you can see that this is 1, 1, 2, 2, but uniform distance. So it's basically every single parameter. And we can take a look at the scoring. So you can see at different splits, you have slightly different results, but it seems like all of them are tied because they actually rank them. But it seems like this, and this are ranked the best. Or if you want to do it more easily, you can just do candidate search.best params. That's another one of the attributes. And from best params, it says n neighbors equal to 4, weights equal to uniform is the best, are our best parameters. Cool. So just like that, we've searched through a bunch of different ones without us having to set up any sort of for loop. We didn't have to set up any sort of, I don't know, we didn't have to set up like a, I don't know, graphs or visualizations or anything. It's all here. Awesome. So what's also really neat about grid search and why you can actually put your grid search into your function as well, by default, what is stored in this KNN search is the model object with the best parameters. So after you fit the grid search, yes, you can get all of this information, but it's also fit on the best params automatically. So therefore, I can actually do .predict, and .predict will do the predictions based on the best performing parameters. So just like this, I can get my confusion matrix, I can get my classification report as well. By that logic, if I'm instantiating this grid search here, I can actually feed this into that function that I had you all set up. And because you're returning the model object, you can actually get these results out as well. If this part doesn't make sense, if what I'm talking about like getting the attributes out of that function doesn't make sense, I'll circle back to it at a one-on-one if y'all like me to. But yeah, grid search, after you instantiate it, it works exactly like a model object. That's what makes it very, very powerful. And yeah, any questions about grid search? Now for any model, and actually I think I have a couple, yeah, I have like a random forest example later as well. For any model that takes in different hyperparameters, you can run a grid search on. So yeah, questions on grid search? Neat. Yeah, it's actually very, very, it is automated. So easy to set up. Well, you just have to do the work of setting up these parameters, but then when you instantiate it, you just have to let it run it. Sometimes if your data sets are big and if your models are one of the longer training models, actually next week's models that we're going to talk about take longer. you might want to set the verbose to be equal to 2 so that you know that work is being done, just for peace of mind. All right, okay, so now that we talked about grid search, let's talk about pipelines. Now, pipelines are neat too, because as I was mentioning before this recording started, I think, pipelines also work as a model object. So pipelines help to reduce some of your pre-processing steps that are, visible in your notebook, I guess. So some models need scaling, for example, and some don't. As an example, k-nearest neighbors needs scaling. But other models like decision tree doesn't need to be scaled, naive Bayes doesn't need to be scaled either. So for those, let's say you want to include scaling for some models, but not all, you could, instead of incorporating scaling into your function that you're writing, you could just have those models as a pipeline. If that doesn't make sense, not to worry. But anyways, pipelines will just allow you to combine steps. So let's just say I know I want to scale my data before it goes into my KNN classifier. All I have to do is set up this pipeline. And the way that a pipeline works is it literally just takes in a list of tuples as steps. Now, the way that you do the steps, the first element, it can pretty much be anything you want. Just know that that's how you're going to pull out information from your pipeline. And then these are going to be the scikit-learn instantiated objects. So once this pipeline is formed, similar to what we were doing earlier, we can do our .fit and .predict. So just like that, that's done. I have my scaled pipeline, and you can rest assured that scikit-learn knows the fit transform on your trained transform on your test, which is nice. And then just like that, we can also get our classification report. Well, this data set is pretty clean, so we can't really see any different results, but that's being done. So that's how you set up a pipeline. In some cases, I don't know if y'all have seen this yet. I will be talking about this at one of the office hours next week, I think. I'll be talking about dealing with class imbalances. Smote is the thing I'm going to talk about. It was in topic 25. I didn't go over it at that time. But if you wanted to, you can actually add smote to your pipeline as well, which is just a way of resampling your data so it's more balanced. So yeah, I'll talk about that when during one of the office hours. But yeah, any questions about pipelines? Neat. Well, from pipelines, as I mentioned, you can access information from your pipeline using like this key that you've defined. So for example, let's just say I want to get from KNN, like the predict probability. I have to go to scaled pipeline, pull out that, and then get the predict prob. So to look at that before I run that first, scaled pipeline 1, you can see that this is my pipeline with the steps. I can pull out my k-nearest neighbors from that. And that's my classifier. And then from the classifier, I can get my predict probabilities. All right, cool. Now from that, what makes our lives even easier is we can actually combine grid search with pipeline. So let's just say that your model that ends up performing the best in your project needs to have some sort of additional pre-processing steps, like you need to scale your data. You can perform a grid search with that too. So how you set that up is same. You want to have the pipeline, and let's just, for this, I'm using a random forest classifier. I know we haven't talked about it yet, but as you all know, all models work the same in scikit-learn. But same way, I'm doing random forest because random forest has a lot of parameters to tune. Same way, I'm setting up my pipeline with a standard scaler and a random forest classifier. Actually, random forest doesn't need scaling, but just to show you all. And then when I define my grid, I have to remember to do this at the beginning. So the way that pipelines work, you can actually also tune other hyperparameters of other parts of the pipeline. So for example, if standard scaler had hyperparameters to tune, you could technically tune those as part of grid search too, which is really cool. But currently we don't have any pre-processing steps that require tuning. But for your grid search to know that you're tuning random forest parameters, you have to do RF, and it has to match this name over here, double underscore, whatever the parameter name is. So random forest has max steps, sample split, sample sleeve. These are actually the same as decision tree, which is what we talked about on Saturday. But yeah, this is how you instantiate your pipeline and define your grid. So once that is done, you can see I'm instantiating my grid search as well. And then with my param grid as this grid, and the estimator is now the pipeline. Actually, let me make a comment here. Estimator is now the pipeline. All the same, scoring is accuracy, and you can do your fit and predict. So just like that, it might take a little bit longer because it's running scaling and a random forest. I think how many times? 1, 2, 8 times, 5, 40 times. So that's done. And from there, you get your best parameters. And again, from your model object, you can pull out information. So this has a little bit more steps because you have to go into grid search. Actually, I don't think you need. Do you need this? Let's try. Okay, yeah. So first you have your grid search object, which has like best params and all that. From there, let me undo this. You can actually grab the best estimator. So GridSearch.best estimator happens to be a pipeline with max depth of 5, sample leave 3, sample split 5. That's great. And then you can pull out the random forest out of that. So RF, which is, oops, wrong one. Best estimator RF. There we go. And then from there, we can get our feature importances. And feature importances, if you remember, that's like a really, really useful attribute to get out of any tree-based model. Random forest is a tree-based model because it's just a bunch of decision trees. We'll talk about that next week. But anyways, if you want to get your feature importances or anything that's an attribute of your grid search pipeline, that's how you do it. I, to be honest, also take a little bit of like fiddling to figure out the order of operations here, but yeah, you can figure it out. And then similarly, yeah, you can get all of your metrics as well. You can get your confusion matrix, your classification report, just the same way as you would any other model object. Therefore, for the function that I had y'all create, it does take in an instantiated model object, and instantiated model object also includes instantiated grid search objects and instantiated pipeline objects. So that's why it's super, super useful to have this function. Cool. This, I would say, this takes a little bit of getting used to. Happy to talk about it, happy to help debug, but yeah, this will definitely streamline your project processes. Any questions about either of these tools before we move into the project?
How would this work with categorical variables? So like if you want to use one hot encoder or something like that, like can it tell the difference, or is there a special way of doing it?
So you can actually use one hot encoder as part of your pipeline. So if you do like a step, well, the steps have to go in the right order. That's important to know. So let's say you want to do, you want to one hot encode your categorical variables, just add one hot encoder as the first step of the pipeline. You can do that.
Okay, and it'll know to, I guess, identify the categorical variables. I guess I don't remember exactly how to use one hot encoder, but.
Oh, good point, good point. Okay, so one hot encoder and the way that it works, it will one hot encode only columns that are objects or categorical. So I guess first you would have to, and I don't think you can do that in a pipeline, but first you would have to change anything you want to one hot encode into an object data type, or create your categories first before feeding your data into the pipeline.
Got it. That, yeah, that makes sense. Thank you.
You're welcome. Cool. Anything else?
Okay, I may have like bad thinking. I may have bad thinking for rationalizing this, but is this kind of almost like you're instantiating, the pipeline is like you're instantiating like the scalar, the model itself, and then you're using GridSearch to find the best combination of the metric of the hyperparameters, and it's not like you're not using the test to train data yet until you fit it with said GridSearch afterwards. I think I'm like just trying to figure out like.
Okay, yeah. So what's happening? Yeah. So under the hood, what's happening is yes, they are for every combination of hyperparameters, they are instantiating a new scalar and a new model. And then they're doing that first. And then when you do the dot fit, actually, yeah, you can think of this as instantiating a bunch of them. And then when you do the dot fit, that's when they're running your chain.
Exactly. Okay. All right.
Yeah. Nice. Mo, you had a question?
Yeah, for input 21, what are the numbers represent?
Oh, these are just values that I want to test for max depth, min sample split, and min sample sweep.
Oh, okay.
So these are just arbitrary numbers that I put in there for now, actually. But yeah, if you wanted, you could go into like random forest. Random forest, that is the regressor. So let's look for classifier. There we go. And so you can see here, I have max depth. It takes in an integer. The default is none. I think the other one I did was min sample split. Default is 2. I wanted to test a couple other numbers. Min sample sweep is 1, and it takes in an integer or float as well. So yeah, I just picked some random numbers based on this.
All right, thank you.
Yeah, you're welcome. And it's usually a good idea to include, especially for your first grid search, it's a good idea to include what the default is just to see if another number does better. Just some grid search tips. But honestly, if you just put a bunch of numbers and run your model and you're doing some form of tuning, that's good enough for me. Nice. Anything else? All right, well, now let's talk about the project then. Cool, so this project, as you could probably guess from all the things that we've been doing, is a classification project. Over here is the prompt overview. You're just gonna have to do, you basically have to solve a classification problem using the data set of your choice. Now, to start, there are 4 provided data sets given here, but if you want to use one of your own, feel free to do so. Just let me know. Some criteria for a data set, it just has to have at least 10 columns, and then it has to have 1,000 rows on average per class. So what that means is if you're doing a binary classification problem with 2 possible outcomes, at least 2,000 rows will be good. If you're doing one with 5 possible outcomes, I want 5,000 rows. That is really just to help your models perform better. So yeah, so data set, if you want to do your own data set, send it to me and let me take a look first before you start working on it. But I do want to talk through some of the curated, some of the data sets on this curated list. There are 4. I'm going to just give a brief rundown of the pros and cons of each so y'all can make your decision. So first, there is a Chicago car crashes data set, which here I think this links to one table that has like all the car crash information. And you can see that there's like crash record, crash dates, speed limit of the area, condition of the traffic, weather condition, the crash type. And I think you have like injury information, so on and so forth. With this data set, some pros and cons. I guess you can see these as either pros or cons, but there are a lot of columns in this data set. I think this data set is also very, very big. Yep, it's 500,000 rows long, and that is going to take a very, very long time for your models to train. Something that I suggest that you do if you want to use this data set is first figure out what you want to predict. So this data set, because there's so many different columns, you can actually get very creative about what you're trying to classify. Now, remember, this is a classification problem, so you're trying to predict some sort of outcome. So some examples of what people have been predicting. A couple people have done whether there are injuries or no injuries in the crash, or like, injury versus no injury. I've also seen type of crash as one of the outcome variables as well. So you do have a little bit of freedom to choose. To make this even more complicated or cool, there are 2 other data sets that you can join and merge with this one that has information about vehicles themselves or the drivers and passengers. Depending on which one you want to use, you can incorporate these as well. You don't have to, but if you want to use that kind of information in your problem, that data is there for you, and they actually have like an ID that you can merge on. So after deciding on what you want to predict, because this data set is so large, If you don't want to spend hours and hours waiting for models to run, I think it's okay to just take a random subset of this data set. So if you want to do that, feel free to do so. Cool. So yeah, it's kind of up to you to decide what your target variable will be. Just make sure it makes sense and give yourself a business case that will support this classification problem. Okay, so the next data set is on Terry traffic stops. It's basically like data for the it's Seattle data for stop and frisk incidents. This data set, basically what people are predicting is outcome of stop and frisk events, which if you take a look at the data set, there is a lot of demographic information. And usually with this kind of sensitive data set, typically you're not really using this for prediction, but a little bit more for inference. So it's not so much like, all right, given this person's persona, will they get stopped and frisked and do they deserve it or not? I mean, not really socially ethical, I guess. So therefore, if you're doing this data set, I do highly recommend that you take a more inferential perspective. So for example, okay, based on the past, I think this is like the past 10 years or of stop and frisk data, doing a study of the patterns that have come through this data set. So for example, if you train a model, you take a look at the important features and take a look and see, or do some sort of coefficient analysis to see what has historically led to people getting stop and frisked. It can be a very, very interesting data set to work with. This one also has a lot of data cleaning involved. Because I think this comes from the police department. A lot of it is manual entry data, so there's a lot of messy data. So up to you how you want to clean that data, but in cleaning that data and getting rid of a lot of those like manual entry rows, you actually get to reduce your data set by a good bit. So up to you if you want to do that. Okay, so that's the second data set. The third one is Seriatel customer churn. And the data basically comes from Seriatel, which is a telco, and it's basically customer retention. I think there's about like 3,000 data points in here. It's the interesting thing about this data set is it's highly imbalanced. So you're just trying to predict whether someone will stay or leave the service based on features like customer service calls, number of minutes used, whether they have like an international phone plan, so on and so forth. So yeah, this is a fairly straightforward in terms of cleaning one, but you can say some really interesting things about customer retention. Cool. The fourth data set is Tanzanian water well data, which is another interesting data set because it is on a bunch of Tanzanian water wells and you're predicting whether they are functional, not functional, or in need of repair. This is an active competition, I think. I think it says April 31st, but I think they've been extending this date for the past 3 years. So I don't know when this competition is ever going to finish. Yeah, there are 3 classes, classification problem on that. This one is interesting because there are a lot of features. And I think getting good results on this one does require a good amount of inspecting what your features are and whether you actually want to use them in your classification or not. This is the only one that is by default a ternary classification problem, meaning there's 3 classes. But if you want, you can also cut it down to 2. It's up to you. Cool. Any questions on any of these data sets? All right, well, I talked about finding your own data, what you should look for. Kaggle, again, is a really good place to source your data. But yeah, at least 10 columns and 1,000 rows per class you're trying to predict. All right, and there's some additional information. I think they have a lot of this information is the same as other projects, so feel free to read that on your own. But I next want to talk about the project process and what that's going to look like. Cool. So I have the guidelines doc. I have already linked it on our homeroom, so it's there for you if you want to take a look at this again. Let me zoom in real quick. Oh, let's take a look at some dates first, because this one's going to be slightly different from how we've usually done it. So today we're doing the project intro, and I guess if we work backwards, we're going to do the presentation on the 22nd. So if you take a look at our timeline, it is actually a little bit less time than we usually do, but I'm also giving y'all the project a little earlier. So I don't know. Basically, usually I have y'all do the presentation on the first day of phase 4, but because we go right into phase 4, we don't have that like extra week of break that we had last time. I'm having the presentation as the last one of phase 3. So take note, the presentation will be in 3 weeks from, is it 3 weeks? Yeah, 3 weeks from today, or 3 weeks from tomorrow. Now, because there's a little bit less time, I'm perfectly okay if your presentation is not on your final model, because you do have the 2 weeks after that to keep working on it. So by dates, I say that the review period is from the 27th to the 8th of October. Of course, the earlier you get the project done, the better, because we go right into phase 4. So yeah, your presentation doesn't have to include your final model. And you can definitely make some conclusions and recommendations on your prior models. Cool. So that is there. Just take note. Presentation will be on this day. I'll mention it a bunch in the next coming weeks anyways. All right, so that's in terms of dates. My suggestions for getting stuff done. Again, you're going to start with some data cleaning and EDA. I suggest about 2 weeks working on that. And the reason 2 weeks of working on that, I think that understanding of your data and setting up of your business case is really going to set you up for success here. And I have something to say about EDA. So I'll say some stuff about EDA later. Your iterative modeling between data cleaning and EDA, if you have that function, iterative modeling is going to be so fast. Those of you who've written that function already, you saw that, you know, it's literally just instantiate whatever model you want to instantiate, run it through the function, and you see your results right away. So I don't think you need as much time for iterative modeling. So that's why I don't give you as many days for that. And other deliverables, basically before the review. Cool. And here I've linked my one-on-one link in case. Any questions about this suggested timeline? The only thing that's not suggested is this presentation date, because that will be the presentation date. If you can't make this usual time, as usual, you'll do your presentation for me during our review. But yeah, for those of you who are new to the cohort, I forget to mention that we do our presentations as a class usually. Cool. Questions about this? All right. So let's talk through a workflow of what this project process is going to look like. At the start, very similar to our last project, start with an introduction and abstract, why you're doing this project, why is it important to classify what you're classifying. I also think this is a really good place to talk about the pros and cons of, or I guess the cons of misclassification. There are no pros to misclassification. And this kind of sets up your metrics. So for example, if you were doing the customer churn data set, I always forget what churn means. Does churn mean the customer leaves or stays? I always forget. But anyways, is it, let's say if you have misclassification in that classification problem, you predict that someone's going to stay if they actually leave, or you predict someone's going to leave if they actually stay. What scenarios what does this mean in your context, in your business context? Who are the people that you want to target? Which one is better than the other? If it's equal, say that as well, but it's important to contextualize your misclassifications. Cool. So that's really just setting up the project. Next, I would say import and clean your data. For EDA, I'm also going to do an office hour session about EDA and effective EDA. I actually might push back some of our models so that I can talk about EDA sooner. I'll let you all know about that. But yeah, perhaps ask some questions about your data. Most importantly for classification, which is actually very similar to what we're doing with regression, how do your features relate to your target variable? Actually, if you take a look at some of the office hours notebooks that are already on the repo, you can sort of see an example of the kind of EDA that would be very beneficial to a classification project. But yeah, I'll go more in depth on that another time. And I'll talk about an alternative for EDA later as well. At this point, you can also do some feature engineering. Of course, now that we talked about pipelines, some of this feature engineering doesn't need to be done at this stage. Some of this feature engineering can be done with the modeling. So this is kind of like up to you and how you want to frame your process. Again, I'm also happy to talk about in your context of your project, what's most efficient, what makes the most sense. And yeah, again, to prevent data leakage, don't do transformations that have to do with the distribution of data before train test split. If you're unsure, feel free to ask. Cool. So you do your train test split. And first you're doing your baseline model. Now in classification, I haven't really talked about baseline model. I know for regression, I said that for baseline model, you just feed whatever data you have into your regression and see how bad your results are and compare everything to that. Now, because for classification, we have so many different models, how you define a baseline can be very different. So a couple ways that you can go about this. One, scikit-learn has this classifier called the dummy classifier that's actually used as a baseline. And it's not machine learning. It is nothing smart. It's basically a bunch of different simple strategies for doing classification. And by simple, I mean like super simple. Like, for example, always predict the most frequent label in your training set. That can be that can be like a baseline. So let's say you have like an 80-20 split on your data set for your class imbalance, for example. If you're picking most frequent for a dummy classifier as your baseline model, you'll start with 80% accuracy and you'll see how you can improve upon that 80%, just as an example. So that can be an example. This can be your baseline model. However, usually what people do though is use vanilla models as your baseline model. So by the way, vanilla models just mean your scikit-learn model with its default parameters. So those are called vanilla models. So for your modeling, I'm going to say at least 4 vanilla models, and you can do this in an automated way. You can do this, well, you should use your function to do it. How you use your function is kind of up to you. But we've hit all of these models. Well, not all of these yet, but we've hit this half of the models. All of these are on their way. But here you can instantiate however many models you want, at least 4, and take a look at their results. So again, reduce your repetitive code by creating some functions and at least fit the vanilla models for 4 different models. But it's up to you how in-depth you want to go before you narrow down your models. So my minimum requirement is after you run your 4 vanilla models or more, I mean, as you know, it's just literally 2 lines if you have a function. But after you've run your 4+ models, just pick your best 1 or 2 to fine tune with GridSearch. So let's say you run like 10 models and you see that, okay, naive Bayes and decision trees did the best. So from that, run your GridSearch on naive Bayes and decision trees, see which one edges out as the best, and that will be your final model. So some things that you can consider here, class imbalances, trying out new features. Maybe you try one version with scaling, one without, even though, for example, I said that like naive Bayes doesn't need scaling, but it's possible that scaling can affect it. So yeah, those are things that you can test out here in this iterative modeling part. So the modeling shouldn't take very long, especially if you have a function already built. Next, after you've narrowed it down to your final model, interpret your metrics. Yes, we're already going to get all of our metrics displayed in our notebook anyways, but give your metrics some context for your final model, especially. Let's say you end up with like a recall of 90% and an accuracy of like 95. What does that mean? It means that overall you're predicting your results correctly 95% of the time, but for a particular class, we're at a 90% recall. What does that mean? Depending on what final model you pick, you might be able to do a feature level analysis. So most commonly, you'll be doing like feature importances. All of the models we're hitting next week all have feature importances. We're going to hit 4 models next week, and they all have feature importances because they're all built off of trees. So you could do that. If you're doing something like logistic regression or naive Bayes, you can look at their coefficients or probabilities, stuff like that. This is kind of optional. If you want, you can do an analysis of your misclassified data to see whether this misclassified data, they're just like outliers or they are really just like one-off weird data that doesn't make sense. I don't know, up to you depending on your data and depending on your model too. Prediction function, I'm going to talk about this during an office hour, but you could actually create a prediction function to take in any data to run through your model. And I'll talk about this and this process of productionalization at one of the office hours as well. Phase 3 project is actually one of the projects that most people end up putting on their portfolio, and doing this step is kind of like step 1 to productionalization. If you ever wanted to like put it on a website or something for people to use your model, that would be step 1. I'll go over that during one of the office hours too. For this project, your recommendations in future, I'm going to be a little bit more nitpicky on this. So recommendations should be quantitative and model driven. Now, what does model driven mean? Try and have it be tied to information that you garner from your model. As most obvious example being like your feature importances. If you have a feature that's very, very strong in determining the classification of your data set, talk about that. I'll talk about the EDA, that EDA thing I meant to talk about right after this too. Have you learned anything from this model about your data set? I'll get more into the philosophy of classification in a couple of weeks too, and I think that's going to help with with talking about this. And then also, yeah, you can draw your conclusions and recommendations from EDA. So what this means is, let's say you have a data set with a lot of features. Let's say you pick the car crashes data set and you decide to like merge all of your columns together and you end up with like 100 different columns. That's going to be a lot to do EDA on. So what's actually a common practice instead is to just take your data set, don't care about the distribution of it first, run it through your models, and based on coefficients, based on feature importances, do EDA on those select features. So a lot of models that are included in this phase, especially the tree-based ones, they will automatically do feature selection for you. If a feature is not useful, it's not going to use it. Of course, including the features will mean that it takes a little bit longer to run, but it will, like having extra redundant features will not hurt your model. It'll just take longer to run. So therefore, what you can do is do your modeling on your 100 columns, whatever, maybe top 5 to 10 that are important, you only need to do EDA on those. And then from your EDA, you can actually draw conclusions being like, oh yeah, okay, this makes sense that customers who churn have a lot of customer service calls in comparison to customers who don't churn, as an example. So you could do something like that. And especially when you already have your modeling results to go off of, sometimes that might be a little bit more of an efficient approach. But approach is kind of up to you as well. And at the end of your notebook, feel free to have an appendix or archives. You can have extra models or your other testing things. I'm like kind of a code hoarder, so I like to keep everything in my notebook, but I keep it in like an archive section at the end. Feel free to do that if you want. I know a lot of you all just do this on a separate notebook, on like a scrapbook notebook, which is also a good practice. So yeah. But yeah, that's the phase 3 project. You kind of have like roughly 3 weeks to work on it before the presentation. Again, I want to highlight that the presentation doesn't have to be like the complete finished project. It's just a non-technical presentation. So if you have like a model by a couple of days before that, you can kind of just pull out information from that model that you're at. But yeah, any questions about this project? I'm gonna kind of, for the rest of the study groups leading up to when this is due, I will be talking about things in relation to this project. So I think that'll be helpful too. But yeah, any questions?
Yeah, just for the Terry traffic stops data set, what would be sort of like a focus for that? What would be the business?
Yeah.
What would
a business case?
Yeah.
Yep. So for that data set, and let me pull it up real quick. For this data set, it's basically any person who was stopped and frisked is a row in this data set. And one of the columns is outcome. So outcome can be no action taken. There's a couple of outcomes, but there's like no action taken. There's like arrests made, or someone was like written. I forget the exact terms for what it was, but what people have done this project on is classify, okay, of all the people who were stopped, how many of them were quote unquote like deserved, because that means they were like arrested, or how many of them were like, I think the right way to say is how many of them were unwarranted, like no action was taken afterwards and they had like no proof to arrest them, if that makes sense.
Right.
And I would say like definitely don't use this classification model as like I can predict who's going to get stopped and frisked, because I don't know, ethical issues around that. But yeah, that's usually the business case that students use for this data set.
Okay. All right. Thank you.
You're welcome. Let me see if I can see the like columns that they have here. Yeah, here you go. You can see that stop resolution. You can see these folks were arrested. I think there's going to be some other pages where it wasn't arrest. I don't know. This data set is also very, very big. Okay, I guess it's going to take a little bit of. Oh, I guess I've sorted by this. Okay, there we go. Referred for prosecution is one. But yeah, those are the values. Cool. Any other questions?
Would you recommend just keeping it like a binary problem and just?
Yes.
All right.
I
Because I'm
think-
just thinking.
Yeah.
Yeah. No. Yeah. Go on.
Yes, I do recommend binary problem just because, especially for your first classification task, it's much easier to do your evaluation if it's binary. It'll also make your lives easier if you're looking at it at a binary, from a binary standpoint. But if you want to do multi-class, all of the models that we talked about expand to or scale to multi-class just fine. So if you want to do that, you can as well. But my recommendation is to try and keep it binary.
Question.
Mm-hmm.
Instead of writing a function, would it be okay to use like lazy predict, which will tell us which classification performs the best or not?
To use like auto ML solutions, like
Yeah.
built-in things.
Yeah.
Okay, so
I want to do it right, but I'm also, I won't lie.
So
I'm
okay, so
also
I've linked some resources down here, and both of this one especially. I don't know if I actually have not heard of the one that you mentioned, Sam, but something that's kind of similar to, I'm guessing what you're talking about, is this library called Teapot, where it actually takes your data and runs it through all models automatically for you, and then just tells you which one the best one is. I think that you can use it. However, I still want to see some element of you comparing different models. So if you're doing this, I still want to see some iterative process of modeling. If you're doing that, I would say I would probably expect to see more from like a grid search standpoint, maybe being more exhaustive in a grid search. But I mean, the point of the project is to get more familiar with classification. So I would prefer if you don't use something like this.
Okay.
But if you want to, you can. I have had a couple students do this on top of doing the regular scikit-learn modeling function process. And you'll actually see that the results are quite different, and doing some sort of comparative analysis of that has been interesting.
Got it. What if we
Yeah.
just used it for like the vanilla modeling portion?
Oh, absolutely. Yeah, you can
That's what
absolutely
I'm more
use it.
meant, not like for the whole project.
Yeah, absolutely. You can use that for the vanilla modeling project. Yeah, portion of the project. So as an example, this is an example output out of Teapot, which will tell you, I forget where it is. Where are the, I don't remember, but basically it shows you a bunch of outputs from a bunch of different models. And I think, I forget if you can, it'll show you the exact best ones, but yeah, I mean, oh, there we go. I don't know. It's kind of up to you to decide. I don't know whether the tool that you're talking about is similar or not, but yeah, if it's just for the vanilla modeling, that's fine.
Sweet. Thank you.
You're welcome. Oh, by the way, the rest of this doc, and you can also add to this doc if you'd like. This is maybe like 3 cohorts worth of questions. So feel free to read through this if you're running into something. these questions have been answered by me. I know they're not super organized, but if you do like, I don't know, Control F and like look for it, you might find something. But yeah, if you want to add something into here, because I don't check this very often, just let me know if you're adding a question, or you can just ask me the question, I'll add it here myself. Yeah, I actually do that instead, rather than me having to come back to this doc to check. But yes, any other questions? All right, well, the office hours topics I'm going to be talking through the notebooks are already on the repo. So I forget the order of it, but we're going to talk a little bit about the philosophy of classification, the separability of data. We're going to talk about effective EDA. We're going to talk about SMOTE, productionalizing as well. So lots of exciting stuff coming. All right. Any final questions before we close out?
Ish, do you have a little bit of time to hang back afterwards?
Yeah, absolutely.
I just wanted a clarification. So the 4 models that we have to do, is it just one per method? So like one decision tree model, one naive
Yes.
phase? Okay.
Yeah.
All right.
Yeah, just pick. Yeah, by 4, I mean like out of this list here, you should pick 4 at least.
And
I would
then-
say like, oh yeah, go ahead.
No, so out of this list, just pick 4, but also run another model that sort of fine tunes it. Is
Yes.
that correct to say?
Run at least one other that you're fine tuning, or one of the 4 you're going to fine tune.
Oh, okay. All
Mhm.
right.
Yeah.
So what if you just like, you did the 4 base models, then you did like a grid search on like, you said, oh, well, naive base was like better. And then you just did like a grid search. Would that suffice? Or would you have to like?
Yeah, that is enough.
Okay.
That's enough. Yep. Of course, like you'll see that if you're doing grid search, you could actually go down like a real rabbit hole because there's like infinite possibilities of things that you can grid search. I just need to see one iteration of grid search. And sometimes you'll see that grid search might not even improve your results because the default parameters are defaults because they perform well most of the time. So yeah, typically through grid search, your results won't improve by a lot, but I just want to see that you're tuning some hyperparameters. Nice. Anything else? All right. Well, Nelson, I'll hang back to chat. The rest of you, I will see you all next week. There's no more study groups for the week. Any project questions, feel free to let me know.
I will bother you, just so you know.
Please do. Please do.
I'm bothering her right now.
All right. Have a good night,
All
guys.
right. Have a good
Good
night,
night.
everybody.
Have a good night, guys.
Thank you. Have a good night, everybody.